Hello everyone, welcome to the Code Code. And did you ever think that why most of the applications which are deployed in a correct way, they are so good when it comes to the speed, when it comes to the browsing, when it comes to the getting response, and how they are able to do it in such a large scale that if billions of users are using that website, that still they are providing you the data which you requested. And this thing happened because of the two components. Those components are CDN and cache servers. So these two components, when you combine them, it will provide you a very optimal way of browsing your application over the internet. In this part, we are going to focus only on the cache servers. We are going to understand the cache from the core. And then in the next part, we are going to understand the CDN so that we will get the full picture that how this thing happened. So before going to CDN, first we need to understand the cache, and without any delay, let's start what we are going to learn, and then we will directly jump to the part where we are going to actually learn the things. Okay, so here it is. And first of all, we are going to understand that why cache is required, from which terminology it comes into the picture. Then, after getting the understanding of what is cache, why cache is required, then we are going to understand what is the local and distributed cache, because it is something which is mainly asked in the interviews, and you will also see this in the articles when you are studying the cache. But most of the engineers don't know that what does it mean by distributed cache. After getting this picture that what is local and distributed, then we are going to learn how to write data into the cache servers, because that is the thing which can provide like which kind of application uses which kind of technique while writing data to the cache servers. Then we are going to understand the cache eviction. First we need to understand what is cache, and then definitely you will get the picture what is mean by cache eviction, because this server have some limited data, and that limited data cannot store all the things. So it means you need to provide some strategy so that the latest data can be available here. That we will understand in the fourth part. After it, we are going to do the scenario mapping. What what does it mean by scenario mapping? Which cache when? Because there are multiple kind of cache, and when to use these cache, we need to understand that too. That is the way only we can understand the large scale of the system design when it comes to the cache. After the fifth, the big three cache failure. So there is also some failures. If we do not care about these three issues, definitely your cache will get failure when you are going to deploy in a large scale system. After sixth part, it's come to the capacity planning math. Means I understood the cache servers, but how many cache servers are required for my application? It is a very big question, and it is very interesting, and it is very simple too. So we are going to understand this math also, that how we can calculate that how many cache servers are required for my application. Okay. After it, the last part, we are going to see the five system design interview questions. These are the common top five interview questions for the cache. Okay. So I guess we get the full picture what we are going to cover in this part. So first, let's start with the library analogy. Okay, so here, if you can see, we have this student, we have the library, we have the basement, and we have the front desk. So for this, what I will do, okay, so first this student will come here, and this student will ask for some book to the librarian that, hey, I need this Python book. I need this Python book and I want to learn the Python. So what the student will do, this student will go to the librarian, and librarian will go to the basement, and that librarian will fetch that book again, and it will come back to the front, sorry, to their desk, and then then this librarian will provide the book to the student. Okay, it is the one flow. Let's say there are thousands of students, they all want the Python book to learn Python. So what will happen? Let's say if there are thousands of students, So in that case, all the students will come to the librarian and they will ask for the Python book. And as per the computers, because they work on the instructions, so if there are 1,000 students, if there are 1,000 requests, so for each request this librarian will go to the basement, this librarian will fetch that Python book and come and give that book to the student. If we do this 1,000 times, that particular librarian will get exhaust and this librarian will stop working. The same thing goes with the computers. If you ask something from the computer to do this, let's say the same task, to do the same task 1,000 times, it might be possible that after some time that computer got exhausted and that computer could stop working. So how we can resolve this issue? So let's say after the first student, when this student came and asked for the Python book for to the librarian, what this librarian did, this librarian went to the basement and this librarian fetched the Python book. After fetching the Python book, it created a copy and save it to the front desk. Let's say there is some drawer beside the front desk, and it saved that Python book at the drawer which is beside to the front desk. Now, after this first student got the book, the another 1,000 students, when they come and ask for the same Python book, this librarian doesn't need to go to the basement right now. Only what this librarian need to do, it just need to provide the copy of that Python book which is already available at the drawer which is beside the front desk, and hand it out to all the 1,000 students. So in this way, the librarian uh, is in a very comfortable place. It do not have to work so hard, and it can also provide the data which is requested. So here, this front desk is the cache. This front desk is the cache, and this basement is the database. And this librarian is the web application or web server. And this student is the, you can say, your client or app or your PC. Anything which is creating a request to the web application comes under the student, and these requests directly will go to the web server. For only a one transaction, it will go to the basement, to the database. It will fetch the data and it will save a copy to the cache server. And then after it, if any other student come and ask for the same data, this librarian will only check in the front desk, or sorry, in the cache server, and provide that particular data to all the other students who are asking for this. So this is the simplest way to understand that what is cache. Cache is something which is storing a copy of your data which you already have at your database, and you cannot go and query the data every time from the database because it is costly when it comes to the resource consumption. Because every time if you are going to query the same data from the database, first of all, it will increase the cost. And the second thing, it is possible that this database server is not able to handle this much of uh, traffic. So we do not want our database to get crashed because it is our soul of the web application. So that is why we need the cache server. Okay, so I guess we understood what cache is. Now let's move to the second slide. Okay, so here the cache topologies and tech stack. What is the local cache and what is the distributed cache? So here local cache means, let's say you have one web server, and inside that web server, uh, these web servers are basically the computers or the data racks. All the computers have this RAM and the hard disk. So when it comes to the RAM of that particular server only, that is called as local cache. Local cache. And when you create a separate server from the web server, let's say, okay, let me just create one diagram here so that we can understand here. So here we have this web server, and this web server is running one application, and this web application is getting used by the user. So when this user is going to ask some data from the web server, let's say your application is used by so many users. So it might be possible that you have this web server 1, this web server 2, this web server 3. And it might be possible the user 1 is going to web server 1, user 2 is going to web server 2, and so on. And the user 3 is going to web server 3. So if you have some uh, server, let's say it is my cache server, which is different from the web server. So it is a one cache server which is connected to all the web servers, server 1, server 2, server 3. So in that case, this cache server is available to all the web servers which are hosting my web application, and it is available to all. This cache server is available to all the web server. It means it is distributed to all the web servers. That is why it is called as distributed cache server. And when it comes to the web server 1, web server 2, web server 3, definitely there is some RAM and the hard disk. So this RAM part is called as the local cache. If you are going to save something inside the web server's RAM, that is called the local cache. And if you are going to use a separate server which is available to all the web servers, even if you scale your web servers for the availability, still that cache server will be available to all the web servers, and that is why it is called as the distributed cache. So when it comes to the distributed cache, mostly we use the Redis or meme cached or hazel cached. These are the technologies which we used depending on the application, that which application which we are using. And local cache is also used in the application that I will tell you that in which scenario we are using the local cache. It might be possible that while studying or with getting conversation with someone, you must have heard about RabbitMQ or Kafka. They are not the cache server. They are the technologies which provide the broker. They are used for the message broker, for the queues. What are the queues? Queues are something which will stack the task, and when the task is scheduled for at some time, or let's say it is for the FIFO purpose or LIFO purpose, last in first out, first out, then it will provide that task to the cache server or some other server, some worker node, and that particular thing will do that work. So this RabbitMQ and Kafka is completely different. We are going to discuss that too, but first after completing the CDN and the uh, cache servers. Okay, so I guess we understood what is local cache, the cache which is available inside the web servers, the basically the RAM, and the distributed cache, the cache which we are using separately and can be used in all the web servers available to your infrastructure. Okay, so this cache topologies are also clear. Okay, let me just go to the next slide. Okay, so here we have arrived to the part where we are going to discuss what are the techniques when we are going to write data into the cache servers. So for that, first of all, we will understand that how the traffic will go from the user to the web server. Okay, so for that, first of all, there is this client app. This client app will, let's say, sending some data. Okay, so this data will go to the web server using the load balancer, because the load balancer, we are going to use these kind of components every time when we are understanding something, so that we will not forget what we have understood till now. Okay, so this client app will send some data to the web server. Let's say this user is submitting some article which that user want to publish. So that client is sending some data to the web server right now. Okay, then after sending this web server, okay, sorry, I have used the wrong example here. So let's say this client is asking for some article from the web server, some web application. So first of all, this client will send a request to the web server. This web server will go to its cache server and check whether this particular article is present or not in my cache server, in my cache database. If not, then it will go to the database, my PostgreSQL, or it can be anything. It will go there and it will ask for that data. And after getting that data, later this data will come to the web server. This web server will send one copy to the client that, okay, yes, I got this article which you have requested, and another copy to the Redis cache. So in this way, this web server are designed so that if anything is missed, which is not available to the cache servers, that can be written at the time when the user is asking for the data. So if again I want to go through the complete, okay, let me just delete it. Okay, here. So this client will request some query to the web server. This web server first it will check the Redis cache. If it is not found, then it will go to the database. This database will revert some data to the web servers. One copy will be sent to user and another copy will be sent to Redis cache. So in this way, this cache servers loads data, and always the first time when something new is queried, the first user will see some lag. See some lag means they have to wait more, because the next time when the second user will come and they will query for the same article, it is already available in the Redis server right now, and this cache server will provide the data immediately. The one more thing which we need to understand, this cache server. These cache servers are mostly RAM, completely RAM, random access memory. These are fast memories. These are fast and temporary memory. And coming to this PostgreSQL or other SQL database, they are the hard drive. They are the hard drive. Hard drives are slow when it compares to the RAM. These ROMs are slow compared to the RAMs. So that is why we need the cache server to provide the response as much fast as possible. Okay, so it is the one technique of cache lazy loading. Now let's come to the next slide. Okay, so right through cache, how this will work. In this technique, what we are trying to do, let's say this time this user is trying to write some data. So this user have one article, and how it will go from this user to web server. The user will send data to the web server. Let's say user is writing some article and they want to store it and post it to the server or to the web application. So first that particular user will send the data to the web server through the load balancer, and now this web server will send this data to the Redis server, this cache server. Now this cache server have the data which is sent by the user. Okay. Now what this cache server will do, this cache server will write the data to the database. Till now, when this user, okay, write this data to the database server, after writing this database server, this 200 response will go to the Redis, sorry, this cache server. This cache server will redirect this response from the web application to the user, and it will state it that whatever the article you have posted, it is submitted. So again, let's go through the flow again so that we will not forget it. Okay. So let's say here is the client, and client want to store some or publish, store or publish article. So what this user will do through the app, this user will send the data to the web application. What this web application will do, till that time, let's say this user have clicked the send button. Okay. So this, after clicking on send, it is required for the web application to send some response. And how this response will come, that is the part which come in the write through cache. So when, after coming to this web server will send the same data to the Redis server or cache server. This cache server will send the data to the main database server, and it will be saved here. Not only saved here, it will be saved here too. So it will save that copy into its own RAM, and also it will send that data to the database server. After saving the data, when this data is saved, it will send back the 200 response to the Redis server or to cache server. This cache server will redirect this 200 to web application. This web application will redirect this 200 to client app, and this user will get the notification it is submitted successfully. Submitted successfully. So in this way, this write through cache works. So it is the technique which is used for the uh, Redis. This particular technique is used when we are going to make some application for the financial transaction or for the banking or for the medical records, because it is very required that whatever the data you are sending, sorry, whatever the data you are sending, it must be saved to the database for the accuracy, and it is required that database must respond the acknowledgement. That is why this write through cache is required in these kind of application. Okay, so we have covered this one too. Now let's go for the another technique, which is the write behind. And how this write behind will work. It is the fastest. And how? Okay, so let's say again there's a client app, there's the user. User will send some data to the web application. And after providing this web application this data, what it will do, it will send to the Redis cache server. And this Redis cache server will not wait for the uh, database server to respond. It will directly send the response back to the user. And when in which case it is required. Let's say you have created a YouTube. Uh, we can use the existing application example. This like YouTube. You have published one video, and after publishing one video, there are 10,000 people who are liking and commenting that video simultaneously. In that case, for all the 10,000s or millions of users writing that data every time for the single video to the database server is too much expensive, and it can exhaust the database. So what we will do, we will store all the things into the RAM and into the cache server, and in a schedule basis we will push all that changes once at the database. So that is why sometimes you see that a YouTube video or some other post gets some delay while updating the count, while updating the views, while updating the likes, even after you have published few things. So in this way, this right behind work. So let's again reiterate it so that we will not forget it. Okay, so we have the client app. Let's say this client is using the YouTube, and this through the YouTube, this client or this user have liked one video. It liked one video. So this YouTube app, what it will do, there is one cache server which will be connected, and this cache server will store likes, all the likes which are liked by the users to it cache server. After just storing it, it will send back the 200 response that okay, yes, it is saved, and the same will be reflected to the application, to the user, that okay, count increased. So it is very fast. Like user do not have to wait for the database to get updated. But after 5 minutes, let's say there is one schedule job which in every 5 minutes take all the changes which are available inside the cache server, and it will write one query, and that query will update the database. So in this way, this write behind technique works. And which kind of application? The big example is YouTube. Okay, so we have understood that how these all things work and what are the techniques. Now let's move for the next part. Okay, so let's come for the LRU eviction, that is called as least recently used. Least recently used means, see, it might be possible that you have a database of 100 GB and you have a cache server of 10 GB only, because RAM is costly. That is why we do not use RAM as much as we are using the hard drive for storing the data. So let's say this 10 GB of RAM priced equally with the 100 GB of my hard disk which I'm using. So I have just 10 GB of RAM which is used as my cache server, and I have this 100 GB of data. So I cannot store all the things into my RAM because I have some limitation of space or some storage. So what what we need the recent data, like whatever the data which is latest, it need to be present in my RAM so that it can be queried by the other user and can get the same response in fastest way. Currently, my Redis server, okay, let me just point it. So currently my this server, this Redis cache, this caching server have three data set C, data set B, data set A. And whenever a user is going to request for data set user A, and this user A is asking for data A. So what it will do, this user will send some request to the web server. This web server will go check in the Redis cache, in the cache server, and it will find that, okay, hey, data A is already present. So it will get the data from the cache server, this data A, and it will revert back to the user A. Now user A is satisfied, and in the very minimum time, this user A got the data. Let's say again, this user A user A came and it requested data D, this data D to the web server. What will happen? Again, this request will go to the web server. This web server will go again to the cache server, and it will check that do I have this data D, and it will find that data A is present, B is present, C is present, but D is not there. Then what it will do? It will ask the DB. It will ask the DB. What this DB will do? This DB will write the data, this data D. It will send the data D to the web server. This web server will send the data D to the cache server, and at the same time it will send the data D to the user A. So now user A is satisfied, but this user A somehow asked some other data or latest data, which is the trending data, and this trending data need to be updated to my cache server. So what this cache server will do, it will remove the least recently used data set. So let's say out of this A, B, C, this C was asked like the last. It was the last query, not like the oldest query, not last query. The oldest query is for the C, and this A, B was new. The query in which this data set A and data set B was asked, it was new, and this the query was the oldest which requested the data C. So what it will do, it will remove the data C, and in place of data C, this data A, data D will come. Sorry, this data D will come here. Here, this data D will come below the data B, A, and D. So in this sequence, now we know that this C was the oldest, then B was less oldest. I don't know that particular word which come between the recent and the oldest. So it is the less oldest, and this DA was the recent. Now the D was asked. So the D will capture the place of recent. This A will move the position to the B, and this B will move to the position of C. So in this way, this LRU eviction work. So whenever a new data is queried, it will replace the oldest data which is available in the cache server. Okay, so this part is also clear. Now let's move to the next one. Okay, catastrophe. Now we are going to understand the system failure, the one thing which can destroy your application. Okay, for this, let's understand one scenario. So currently I have one application which is running perfectly fine, and some junior engineer was assigned to some task, and somehow they have updated that uh, uh, all the keys which can live on the cache server is for 60 minutes. Okay, so this is the scenario. So here is my cache server. Okay, let me just enable the pen. Fine. Okay, so here it is. It is my cache server, and what it will do, like this cache server mainly save data in the form of key and value. Okay, so in this way, this cache server will save the data. And what this junior engineer did, this junior engineer updated the timeout. And how they updated the timeout? They updated the timeout in a way that if in 60 minutes this particular key is not requested, then delete it so that other keys can take some place if required. Sorry. And what happened that because of some maintenance and some other activity, all the keys were isolated for 60 minutes and then got deleted automatically because it was configured to the cache server. Right now, my cache server is empty. There is no data in it because of this thing. So what will happen? Uh, let's say there are thousands of users. Again, when your system goes up, these thousands of users will go and ask for some data to the web application. This web application will go and ask the same to the cache server. Cache server is empty. Then it will send these simultaneous thousand requests to the database, and this database will not able to handle it because databases are fragile and it will take so much resources, and it is not configured to take 1,000 requests at the same time because it might be possible that your web application is hosted over hundreds of web servers, and those hundreds of web servers are getting used by around thousands of users. It might be possible that thousands of users got some news from the AI and they are going to query in your web application. So in that case, all the request will come back to the database server and it will crash that. It will crash it. So this is the scenario which we do not want while working with the application. So for that, we need to create a system for deleting the keys which are not getting used with the 50 to 70 minutes of cycle. So let's say for some portion it should be 50 minutes. For some portion it should be 70 minutes. So in this way, a few keys will be available, few keys will be not available, and our system will not go down completely. It will go, it will check, and it will fill the data which is required. Okay, so it is the cache avalanche. And now let's move to the next part. Hmm. Which cache when scenario mapping? Okay, so for the user session storage, we will go for all the four blocks. Okay, so in a microservice architecture, a user might hit server one on their first click and web server two on their second click. It might be possible. So if you use a local cache, server two won't have the data like in which you have logged in. Again, let me reiterate the scenario. So for the user session storage, why cannot we use the local RAM? Why we should use the distributed RAM or distributed cache server? So if you are going to use the local server or local RAM, so let's say at the login time, you have provided your data and you got successfully logged in, and this particular progress is saved at the server one. But let's say if you are going to use the some feature inside the application, and that particular application feature will route you to the server 2, and in server 2 there is no data which is available from the cache of server 1. So this server 2 don't know that you even logged in. So in that case, that server 2 will not uh, entertain your request. So in this way, we understood that if user session storage we need to create, then it should be distributed. Okay, live view counts. So let's example, if Mr. Beast, sorry, if Mr. Beast drops a video, the view counter increments 10,000 times a second. So if you write that to a PostgreSQL database, it will instantly crash down. Why? Because 10,000 queries. So let's say there are 10,000 people which are hitting the like button at the same time. It means 10,000 queries or 10,000 response are getting uh, to the getting to the getting to the database server at the same time. That is not good. So what we need a cache server which will take data, which will hold the data for a certain period of time, and after that certain period of time, in a single query, it will update that data to the database. So we have understood that, okay, this technology we have earlier we have understood that what technology which is it? It was the right behind, and again it need the distributed Redis. We cannot use the local one because uh, this particular likes are coming from all around the world, and they all likes which are coming, they will be going to different web servers, and we cannot calculate these kind of data by going to each server. So that is why we need a distributed cache server. Coming to the home page configuration, for that we can use the local cache. We do not need the uh, distributed cache. Why? Because let's say your web application is running on a web server, and this web application, definitely it will load the index.html, it will load some images, and it will load some css, and that particular thing you can provide inside the RAM of your local inside the local cache of your web server. So every time when a user will come, user will go and send a request to access your application, and that application will provide the data which is already present inside its local RAM. So here in this case, we do not need the distributed RAM. You can save these kind of things in all the web servers which are static. So again, it comes to the point of static. If things are static, you can use the local cache servers. Now comes to the expensive DB queries. For this, we need the distributed cache without any question. So imagine if you are running one company, and inside that company you are running some queries. That particular query will take time around 10 to 20 seconds to calculate all the things, and it means that when you are querying something data from the database, it means it is a resource intensive query, and you do not want 10,000 people to do the same things to the database server which you have for your web application, because it stored these sensitive things and it cannot go down. So in that case, you just want something that one user will come and do this operation, and the data from this query will be stored some in cache server, and all the other thousands of user will come and use that cache server. So in this way, for the expensive DB queries, we must use the distributed cache, not the local cache. And I guess we have just understood the concept of caching. Like they somehow use the same methods every time when it comes to the question of regarding like which cache should be used, because these scenarios are common to all the application. Okay, so we have covered this one. Now here comes the interesting part: how we can plan, like how many cache servers we need. Capacity planning, how many servers? Okay, so this is the very interesting part. In this part, we are going to understand that how many cache servers we are going to need when it comes to our application. So for that, we need to understand one word that is called the active data set. Active data set means the data set which is being queried at the time, the hot data, which is called as also the hot data. It is the data which is most of the time gets queried by the user. So it is the active data set, and let's say it is of 100 GB. So there are thousands of customers which are using your application, and that application is providing 100 GB of hot data, the active data set. This 100 GB of active data set must be present at your cache server, must be present at your cache server. So it means your cache server must be of 100 GB RAM. But we cannot exhaust the complete cache server. with this 100 GB. So we will take 20% cap on it. So what it will become? It will become 120 GB, 120 GB RAM cache server, cache server to hold the 100 GB of active data set. And coming to the calculation, like how many servers we need. So for right now, we got to know that because of hot data, because of active data set, we have the data. We need the RAM of 120 GB. And when it comes to AWS EC2, AWS EC2, let's say I have one server with 32 GB RAM, 32 GB RAM, then how it will become 120 divided by 32. It means the total GB which we need and the GB which is present inside the one system. It will provide me something around 3.75. It means servers we need four servers we need to handle this 120 GB of cache server for the 100 GB of hot data. It might be possible that you have some servers which can have different RAM size, either of 16 GB, 64 GB, it can be anything. So you can calculate in this way that how many servers you're gonna need. But still, there is one more thing. Not only active data is required. So first we will remember this four servers we need for the active data set. Let me clear it so that we can go for the next metrics. What is the next metrics? That is the throughput. THROUGHT throughput. Okay, sorry. This throughput. Uh, Memory isn't everything. What if that 120 GB of data is being requested 500,000 times per second? So let's say you have that particular 100 GB data, which is available inside the 120 GB of RAM, and that is being requested by half of the million people per second. Because it might be possible, it is possible for the Google, it is possible for the Amazon, and the others, Instagram, Facebook. These all applications are providing same data to billions of users. So it means only memory is not required. We need something more that is called as throughput, the network, the CPU. So let's say one. So there is some limitation to the servers also. So currently we have the four servers which we calculated earlier. And each server can handle 1,000, 100,000, 100,000 requests per second. So these are the limitations of the hardware that you should know, because it might be possible that this server you are using of some different quality or some different version. So these requests per second volumes can be changed. But for example, we are taking here this, it is the 100,000, and currently we have the 500,000 requests per second at the peak per second. So here we have the 100,000 requests per second for the each server it can handle. So what we need is we need the five servers. So four servers we got for the 120 GB, and at least five servers we need to handle 500,000, half of the million requests per second by the users. So after calculating this four servers and five servers, we need to pick the maximum. And what is the max? Five. So we got the count, like how many servers we need to handle 100 GB of active data set, and which can be queried by the 500,000 people per second. So it was a very interesting thing, but it is very basic. So these are the basic things which which people think is very complicated, but it is not. All you need to know is that which hardware you are using and what are the limitation of that hardware. It is not required for everyone to know everything about the hardwares. All the documents are present. All you just need to know the approach, that what approach you are going to use while calculating the things. So in this way, we are going to calculate that how many servers we are going to require when it comes to this kind of active data set and these many requests per second. Okay, so this part is done. Let's go for the next one. Okay, so we have reached to the interview questions, and I guess we have understood all the concepts thoroughly. So let's go and check for the questions and answers as well. Cache penetration versus cache avalanche. Hacker requests a key that doesn't exist. It misses cache and hammers DB fix cache empty and null request. Okay, so this is also something which can create issue for your cache. And what is this? Let's say there is some data which is not available inside your DB server. Let's say there are 100 users and 100 users have ID of from 1 to 100, and there is some hacker which is trying to inject a query with the user ID of 1000, 1000, yeah, but that 1000 user ID is not present. So every time what it will do, it will go to the cache server. Inside the cache it will not get, then this particular request will be sent to DB server, but again this DB server will also not have. And let's say uh, if the same thing hacker do in the scale of 1000 to 10,000, what will happen? So all the 1000 or 10,000 requests will go to your web servers. This web server will send this request to the cache server. Again, it will be not there, and all the requests simultaneously go to your database server, and it will crash it. So we do not want all the things to be get crashed. So what we need a mechanism that is called the jitter, and it will do not jitter. Sorry, we need to we need to handle it at the application level. So that is comes inside the penetration. And coming to the avalanche, we have understood what this avalanche is, and to fix it, there is a method called jitter. I want you to go and check what this jitter is. If you are not getting the answer, then definitely I will tell you. Okay. So write through versus write behind. Okay, write through synchronous write to cache and DB, safe but slow. Okay, and write behind, write to cache, return successfully instantly, sync to DB later, instant, insanely fast but dangerous if cache get crashed. Okay, so we have understood this write through and write behind also earlier. Okay, what is cache breakdown? Again, a highly viral key expires in that millisecond. 10,000 requests miss the cache and hit the database simultaneously. Use the mutex lock so only one request goes to the DB to fetch it while other wait. Okay, so this is also fine. If we use a local cache, what is the major downside? In a system with multiple web servers, local cache don't share data. I guess this is all the questions which we have covered till now. And why not put everything in the cache? Cache cost, because these are the very costly. RAMs are very costly, so that is why we cannot put everything in it. That is why we need the database server. Okay, so I guess if we use a local cache, what is the major downside? The local cache server will be available to server one only. All the other servers will not get the data which is available inside the server one. So that is why it is the main major downside. Why we should not use the local cache? Why not put? I guess it is very easy question. This cache breakdown we understood, and we also got one new word, mutex, and it also provide the answers also. The lock, so only one request goes to the DB to fetch while other wait. Okay, these are the very basic question. I guess after understanding the complete scenario, all the answers you can see are repeating whatever that we have discussed till now. So that is it for this video. In the next part, we are going to talk about the CDN. And after understanding the CDN, we are going to link our complete structure of CDN and cache server to each other. And also we are going to understand that how many CDNs are required when it comes to application to go globally. So that is it for the video. And if you like it, then share, subscribe. And if you have any question, then let me know into the comment section. I will definitely help it. Thank you.